Hello, this is lesson 3.4, quadratic functions and applications. Um, so we're gonna go ahead and look at quadratic functions and some of their characteristics and so on. We have two different forms for quadratic functions. One of them is f of x equals ax squared plus bx plus c. And this is the standard form. Now, in this standard form, a cannot equal 0 because if a equals 0, oops, I'm missing bx plus c. So if a equals 0, then this would be a linear function because it would only have the bx plus c. But when we have a that is not a 0, it's a quadratic function. Now, we have another form for the quadratic function, which is f of x equals a times x minus h squared plus k. And with this one as well, a cannot equal 0. This form is called the vertex form. Now, we have a quadratic function right here. And we're going to go ahead and go over some of the characteristics um, of this quadratic function. So first, we're going to look at x-intercepts. X-intercepts are the points where it crosses the x-axis. So we have 1, 0, and 3, 0. Both of these are the x-intercepts. So 1, 0, and 3, 0. Actually should do and. Um, the x-intercepts are also called the roots or the solutions, just so you know. Okay, next let's look at y-intercept. So that's where it crosses the y-axis. Um, that point is right here. 0, 3 is the y-intercept. Now, next, we have what's called a vertex. Vertex is the point where it kind of turns. So in this upward parabola, it is the lowest point, but if this is flipped to a downward, then it would be the highest point. So vertex for this one would be 2, -1. Now, um, for this, like I said, for this one, this is also called the minimum. And now the vertex, this 2, -1, is the point HK. So when we look at our vertex form here, we have an H when we have an K. So we would plug in the H and the K from the vertex. Okay, next one, which for some reason it's not on here. Um, Let me just make sure that this looks all fine. I thought I double checked it, but I guess I didn't. For some reason, this is missing. Oh, now it showed up. That was interesting. So it's asking if it's a maximum or a minimum. Well, we just talked about it, that the vertex, because it's the lowest point, it is the minimum. Next is the axis of symmetry, and that axis is a line that if we fold this graph along that line, the points would go on top of each other. So axis of symmetry for this one is right here. For a quadratic function, the axis of symmetry always goes through the vertex. So the axis of symmetry is x equals 2. Okay, domain. If we look at this graph here, we can see that it keeps going and going for both directions, the negative x's and the positive x's. So it is all real numbers, or again, we can write it as negative infinity to infinity. The range, if we look at that, the y values start, so the minimum y value is -1, and that is included, and we go all the way up to infinity. So there is no y values that are below that -1, below the vertex. So that's why we start at -1 and go all the way to infinity. They keep going and going. Now, transformations from the parent function. So what has been done here? If we look at, um, compare it to the origin, it's gone 1, 2 to the right. So 2 right, and then it has gone 1 down because the vertex is right here. Okay. Next, we're gonna find the or okay, actually, we're not gonna find the y-intercepts for this one because we don't have the actual um equation. We just have the graph. We already found them. What this explains is how you would find. So we're reviewing how to find the y-intercept and the x-intercepts. So to find the y-intercept, you want to find f of 0. So we set x to equal 0. For the x-intercepts, we set f of x to equal 0, and then we solve. So y equals 0, just like we've done with the linear equation or linear functions. Okay, next we're going to graph the transfer function with its parent. So we want to graph the parent first. Our parent function starts at 0, 0. So the parent function is the y equals x squared. And now if we plot those points here for that, for the parent function, x and y equals x squared, we get 0, 0. If we do x equals 1, y is 1. If we do x equals 2, then y equals 4. 2 squared is 4. So 1, 1, and 1, 2, 3, 4 right here. Now it's the exact same on the opposite side. So it's -1 and 1 and -2 and 4 because it mirrors it. So if I try to sketch this, it goes like this. There we go. That is the parent function. Now, let's look at this, what we have here. We have y equals x plus 2 squared minus 9. Now, this is in the vertex form. Y equals x minus h squared plus k, right? It looks exactly like that. Now, remember that our vertex is hk. So this is what's called the vertex form. So now if we look at these numbers here, our vertex first we have to make sure that we notice that there's a negative between the x and the h. So since we have x plus 2, it has to be the opposite. So it's going to be negative 2. And then our k is the negative 9. So our vertex is negative 2, negative 9. So we know that it's going to be the vertex is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 down here. This is our vertex. And so what happens is we're going to keep, going up from, or it's still an upward because it's a positive. What we want to find next to help us graph it is the y-intercept. So remember that when we find that, we said x2 equals 0. So y equals 0 plus 2 squared minus 9. So y equals 4 minus 9 equals negative 5. So our y-intercept is 0, negative 5. We're going to plot that point here. 1, 2, 3, 4, 5. There's our 0, negative 5 right here. And then, so that was our y-intercept. Then we're going to do our x-intercepts. Y equals 0. So 0 equals x plus 2 squared minus 9. We're adding the 9. And let me actually draw a line here so that I know where I'm going. 9 equals x plus 2 squared. We have a squared here. We take the opposite, which is a square root. We have to add a positive and negative because we're taking a square root. Square root of 9 is 3, so we have a positive and negative. 3 equals x plus 2. So what this means is that we have two different ones. We have a x plus 2 equals negative 3 or x plus 2 equals positive 3. So we subtract 2 from both sides and we get x equals negative 5 or x equals 1. So this means that our x-intercepts are negative 5 and 0 and 1 and 0. So negative 5, 1, 2, 3, 4, negative 5 right here, and 1 and 0 right here. Okay, now we have enough points that we can actually graph it here. It's going to go up like this, and then on the other side, it's going to do the same thing here. Okay, the last thing that we need to look at is what is its domain. Well, domain for all quadratic functions is going to be negative infinity to infinity or all real numbers. Either one is correct. And our range, that's the one that's going to be a little bit different. So again, we start where the vertex is. Our lowest point, the y-coordinate of the vertex is negative 9. That is included, and we're going upward, so it's going to be all the way to infinity. Okay, let's look at this next one here. Same thing, we have our parent function is, again, y equals x squared. So we already plotted the points or did the table 1, 2, 3, 4 for the parent function. So we're just going to go ahead and graph the same thing here. Now, we have a question. Does the parabola open up or down? Well, this negative right here tells us that it's going to open down. What is our vertex? Remember, our vertex form is y equals x minus h squared plus k. HK is our vertex, so here it's 3, 2. Next is that it's asking what is our y-intercept. So our y-intercept, um, for our y-intercept, what we do is we set x2 equals 0. So we're just going to plug in that y minus 0 minus 3 squared plus 2. So y equals negative. So this is negative 3 squared plus 2. Negative 3 squared is a 9, but we have that negative outside, so y equals negative 7. So our y-intercept is 0, negative 7. Okay, hold on. I did not graph the vertex. 1, 2, 3, 1, 2. Here's our vertex, 3, 2. And we're going in the correct direction because we are going down. 1, 2, 3, 4, 5, 6, 7. Here's our 0, negative 7. Next, x-intercept. So that's the one that, again, we need to solve here. So x-intercept means that y is going to be 0. So 0 equals negative x minus 3 squared plus 2. We're going to subtract 2 from both sides, and now I don't have room to do it all down here, which I would like to because it helps with not making mistakes. Negative 2 equals negative x minus 3 squared. We want to get rid of this negative right here, so we are dividing by negative 1. Remember that there's a 1 that we don't write over here. So we get 2 equals x minus 3 squared. Now, the opposite of the squared is a square root, so we're going to take a square root, and again, positive and negative. So we end up with, I'm going to flip this over to x minus 3, so I'm just switching the right and the left and doing nothing else. Plus minus square root of 2. And now, so we end up with x minus 3 equals square root of 2, or x minus 3 equals negative square root of 2. We add 3 to all of these, and we get x equals 3 plus square root of 2, or x equals 3 minus square root of 2. So our x-intercepts, let's see if I can fit them here, are going to be 3 plus square root of 2, 0, and 3 minus square root of 2, 0. Now, are we able to graph them like this? No, we're not. So what we need to do is we need to actually use the calculator and get an approximate with 1 decimal so that we have an idea. So the 3 plus square root of 2 is going to be 4.4 when we plug it in the calculator. And the 3 minus square root of 2 is 1.6. Now it's a little bit easier to actually graph them. So 4.4, 1, 2, 3, 4.4 is somewhere here. And then 1.6 is 1 and somewhere right here. Okay, now we can actually go ahead through the points that we've got and sketch the quadratic function. Okay, does this one have a maximum or a minimum? Well, if we look at it, it's on the top here, so it has a maximum. Now, the maximum of the of is the y value. So it's a maximum of 2. That's the y value of the vertex at x equals 3. The 3 comes from the vertex again. So this 2 and the 3 come from the vertex, the coordinates. Maximum of 2, so the maximum value of this is a 2 because the vertex is a 2 and it's an downward opening. and it is at x equals 3 because the vertex x coordinate is 3. Okay, next we look at axis of symmetry. The axis of symmetry is always the same as the x coordinate of the vertex. It always goes through here. So that is x equals 3 also. So these two should be the same, or are the same for the quadratic functions. Now, domain is just like any other quadratic function. It is all real numbers, so it goes from negative infinity to infinity. And the range, now we start from the smallest, and since the vertex is at a maximum, we need to, the y values continue and continue, so we start with the negative infinity, and we go all the way to 2, which is the vertex, and 2 is included. So there's your range. Okay, next one. So what we were looking at here, this is um, so-called graphing form. So when we have it in the vertex form, it's easy to graph. We can just plug in the h and the k. So we have, when we are given the standard form, f of x equals ax squared plus bx plus c. This is not as easy. We don't know what the vertex is from here. So what we need to do is find it. And to find h, so that's the h is the x coordinate, we would calculate negative b divided by 2 times a. So this is the x coordinate of the vertex. Remember, we already talked about the vertex being hk. And now, then after we find the x, to find k, our y coordinate, plug h into f of x. Okay, so let's go ahead and look at this next one here. Y equals negative x squared minus 4x plus 5. So remember that this is the form y equals ax squared plus bx plus c. So what we want to do is look at our a here is negative 1. There is a 1 between the negative and the x, but we just don't write it. Our b is negative 4, and our c is 5. Okay? Now, our first question is, does the parabola open up or down? Based on this negative sign right here, it is opening down. A is negative 1, which is less than 0. So that is why it opens down. Okay, now we need to calculate the vertex. So remember, we were given the formula for the h here. So h equals negative, our b is negative 4 divided by 2 times negative 1. Okay, what I'm going to do is I'm going to count the negatives. I have 3 negatives, so my answer has to be a negative. And then 2 times 1 is 2, 4 divided by 2 is 2. So our answer is going to be negative, our h is going to be negative 2. Now we need our k. So again, to find k, plug h into f of x. So we're going to do y equals negative 2 inside parentheses squared minus 4 times negative 2 plus 5. Okay, negative 4 plus 8 plus 5 gives us a 9. So our y coordinate of the vertex is going to be 9. So -2 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here. It's a good thing it opens down. Okay, x-intercept. No, y-intercept first. Um, y-intercept means that x is going to be a 0. So y equals -0 squared minus 4 times 0 plus 5. When we do this, we get y equals 5. So our y-intercept is going to be 0, 5. 0, 1, 2, 3, 4, 5 is right here. Our x-intercept is when we set y to equal 0. So 0 equals negative, where am I? X squared minus 4x plus 5. Okay, so this is the one that is a little bit kind of a trickier thing. What we need here is solving the quadratic equation. So we either can use a quadratic formula always, or what we can do is we can factor this. What I'm going to do is I'm going to bring the negative outside and do x squared plus 4x minus 5 equals 0. So if we look at this now, it's a little bit easier. Um, Now, depending on how you've learned to factor, what we're looking for are factors of -5 that add up to 4. Or if you've learned the AC method, 1 times -5 is -5 and 4. So now we're looking for factors of -5 add up to 4. And our factors are going to be 1 and, hold on, no, -1 and +5. -1 times 5 is a -5, and -1 plus 5 is a 4. Okay, so there's one more thing that okay, yeah. So we got our factors. So it would be x minus 1 times x plus 5 equals 0. Don't forget the negative sign in the front. But now what we're going to do is divide by the -1. So this disappears and we get x minus 1 equals 0, or x plus 5. No, not x plus 5 equals 0. So when we move the -1, we get x equals 1 or x equals -5. And those are our x-intercepts. So 1, 0 and -5, 0. So 1, 0 is here, and -1, 2, 3, 4, 5. -5 is 0 is here. Okay, let's graph now since we have enough points. All the way up and then back down over here. There we go. Now, next question is does it have a maximum or a minimum? Well, it's a downward, so it has a maximum of, now remember that of is the y value, so maximum of 9 at x equals -2. Again, -2, 9 is your vertex, and that's where those two come from. Axis of symmetry is going to be the same as the x value of the vertex, so x equals -2. Domain is always all real numbers, or negative infinity to infinity. Range, we're going to start from the negative side. So we're going to start from negative infinity because that's where it comes from. And then our max value is 9. And that is included. Okay, next one here is going to be y equals x squared minus 10x plus 20. Again, we're going to look at the form here, ax squared plus bx plus c. Our a is 1, b is negative 10, and c is 20. Okay, does the parabola open up or down? If we look at the sign, we know that it's going to be an up because a, which is 1, is greater than 0. Our vertex now, again, that's something we need to calculate. So h equals negative b divided by 2a. Negative our b is negative 10, and 2 times 1. We have 2 negatives, so it's a positive. 10 divided by 2 is a 5. So the x value is going to be 5 of the vertex. Now we plug the 5 in to calculate the h. No, sorry, the k. We plug the 5 in to get the k. So y equals 5 squared minus 10 times 5 plus 20. And when we plug this in the calculator, we get y equals negative 5. So our vertex is 5, 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, and negative. There we go. 5, negative 5. Okay, next we need our y-intercept. So that means that we're going to set x2 equals 0. So y equals 0 squared minus 10 times 0 plus 20. Y equals 20. 0, 20. Well, that's going to be interesting. That's actually something that we're not going to be able to graph on here because we're going to go way over. This goes only to 10. So let's look at our x-intercepts. If we're able to kind of graph it with just those two. So our x-intercept, I'm going to do it here. X-intercept means that we're going to set y2 equals 0. So 0 equals x squared minus 10x plus 20. And again, we could try looking for factors of 20 that add up to negative 10. Well, there's not going to be, we're not going to be able to find it. So what we're going to use here is the quadratic formula, which the quadratic formula is x equals negative b plus minus b squared minus 4ac square root of this divided by 2a. Now, we already have our a, b, and c over here. So what we're just going to do is plug those in. So x equals negative 10 plus minus negative 10 squared minus 4 times a, which is 1, times c, which is 20, divided by 2 times 1. And now x equals, no, that was not what I wanted to do. I don't need the x here. Negative and then negative become a positive. 10 plus minus. Inside the square root, we're going to get 100 minus 80, which is a 20, divided by 2. So what we get here, 20, we can break down um, to 4 times 5. So 10 positive and negative, 4 times 5. And why did I do that? Because 4 is a perfect square. So I can take out square root of 4, which is 2, and then leave the square root of 5 in, and we have a 2 here. Now what we can do is divide by the 2 all of these, so we get 5 plus minus square root of 5. Okay, so our um, x-intercepts are going to be 5 minus square root of 5, 0, and 5 plus square root of 5, and 0. Okay, now we need approximate values for these for us to actually graph it. So 5 plus square root of 5, if we plug it in the calculator, we get 7.2. 5 minus square root of 5, we plug it in the calculator, we get 2.8. So 2.8, 1, 2, right here, and 7.2, 3, 4, 5, 6, 7.2 is somewhere here. So those are our x-intercepts. Now, with these 3 points, we are actually able to graph it. So we can go from here and keep going up, and from this side, keep going up here also. Now, if we look at this parabola, we can see that it opens up like we already stated here. So we have a minimum, and our minimum is again the y value of the vertex, which is -5, and it is at x equals 5. Okay, axis of symmetry again goes through the vertex, so it has to be the same as the x value of the vertex, or x coordinate of the vertex. So x equals 5 is our axis of symmetry. Domain for all quadratic functions is -infinity to infinity, all real numbers. Our range, since we have a minimum, we're going to look at what the minimum is, which in this case, it is -5 where it starts from, and it goes all the way to infinity. Okay. Now we're going to look at a few applications which use quadratic functions. So we have here a bullet is fired upward from ground level. Its height above the ground in feet at time t seconds is given by the function h of t minus, I'm sorry, -16t squared plus 960t. Now, if we look at this, it is in the standard form. Our a is -16, our b is 960. Remember a x squared plus bx plus c. We're going to find the vertex, which is our hk, and that one we got the formula h equals -b over 2a. So our b is 960, 2 times -16. When we plug this in, and now we have 2 negatives, so we know that we're going to have a positive answer. So 960 divided by 2 times 16 is 30. That is our h coordinate of the vertex. To find our k coordinate, we're going to plug in that 30 into this equation that we're given, -16, 30 squared plus 960 times 30. We get 14,400. So our HK, so this is our K, the vertex is going to be 30, 14,400. Now, what we actually want to do before we move any further is we want to do a little sketch of this. So what happens here is x is always time. And in this case, y is going to be height. And height is in feet, yes. Time is in seconds. So how does it look? We're going to start from 0, 0. So we start from the ground because it is fired from ground level. So we're going to start from the ground, go up, and then it comes down, right? Our vertex is this point right here, which is 14,400. Now, find the time at which the bullet reaches its maximum height. Where's the maximum height? The maximum height is here. Our time is the x value, so it's going to be 30 seconds. Next, we need to find the maximum height. Well, that's part of the vertex too, since it is a downward. So our maximum height is going to be 14,400 feet. Our next question is find the time at which the bullet hits the ground when the height is equal to 0. So that means that our h of t is going to be 0. So we're going to set the equation to be 0. So actually, negative 16 t squared plus 960 t equals 0. Now, this one is easiest if we take out the greatest common factor here, which would be negative 16 and t. So when we take that out, we are left with t minus 60. And now what we can do is we can do negative 16t equals 0. So we divide by negative 16 and t equals 0. Or we have the other one, which is t minus 60 equals 0. We add 60 to both sides. So we get t equals 60. Again, this is t. So which one is the one? Find the time at which the bullet hits the ground. So we start from t equals 0. The bullet comes back to the ground when t is 60 seconds. Okay, one more example. A store owner finds that a price of P dollars, X units of a certain item will be sold. The demand as given by the function P of X equals 84 minus 2X. Recall that R of X, which is price times quantity. So find the following, the revenue function first. So R of X, again, is price times quantity. So P of X times X. So 84 minus 2X times X, we distribute 84X minus X 2X squared. So our revenue function is negative 2x squared plus 84x. We usually want to write them in an descending order of the exponents. Okay, so that is our revenue function. Now, the number of items that leads to the maximum revenue. We know that it's going to be a maximum because it is a downward. Our vertex is going to be here. So let's look at our vertex then. H equals, again, it's negative b over 2a. And now we did not write down our b or the. So with this, a equals negative 2 and b equals 84. So negative 84 divided by 2 times negative 2. Or its h is going to be 21. So the number of items items that leads to the maximum revenue. So this is the number of items that leads to the maximum revenue. So it is going to be 21 units. Um, that is our x coordinate. Now, our next question is the maximum revenue. Well, that's where we plug this in. So R of 21 equals -2 times 21 squared plus 84 times 21 equals $882. So this here is the maximum revenue when they sell 21 units. Okay, that's it for this lesson. Again, let me know if you have any questions. Bye.